Uh, Good evening, dear participants. Uh,
Good,
my humble yes, my humble
good
request.
evening.
Yes, good evening, good evening. My humble request to all, please mute your mic and as well as your video also. Okay. So today we are going to discuss the. Okay. Now, please inform me. Can you hear this slide?
Yes, sir.
Yes, sir. Visible, sir.
Okay.
Yes,
Visible.
sir.
Thank you, thank you,
Yes,
thank you,
sir.
thank, thank, thank you,
Yes,
thank
sir.
you, thank you. Okay, let's start. Uh, Dear students, today we will discuss assumptions of parametric tests. Uh, okay, so I just okay. Thank you. Okay. Now today we are going to discuss the two topic. One is assumptions of parametric test, and after this we will take parametric and non-parametric test. Okay. So first of all, we should understand what is a parametric test and how parametric test different from the other non-parametric test. And so, but before starting the parametric and non-parametric test, we should know or idea of the assumptions of parametric test. Is it clear? Now, the assumptions of parametric tests, basically the main four assumptions of parametric test. One is okay. Yes, yes. Okay, the assumptions of parametric test. Basically, there are four types of assumptions in a parametric test. One is data should be normally distributed. One is the data should be normally distributed, and another, the data should be homogeneous, and third, data should be continuous, ordinal, and continuous data, and fourth, it is independent score. Independent score. Take minute. I'm trying to my pen. Okay. I think there is problem. Okay. Okay. The there basically there are four types of assumptions in the parametric test, but the two assumptions very important performing the parametric test. One is data should be normally distributed, and another is data should be homogeneous. So what does it mean, homogeneous? And uh, uh, the understand the assumptions of normality. Okay. So assumptions of the first assumption is data should be normally distributed. What does it mean? So when we apply any parametric test, either independent t-test, pair t-test, ANOVA, repeated measures ANOVA, or whatever the parametric test we are using. So before applying the parametric test, we should check the normality and homogeneity of the data. Okay. Now, say there are four basic assumptions. One is normal, homogeneous, and ordinal. And the third condition is our data should be ordinal or continuous data. And fourth is independent score. It means the one person score should be independent to other. So, but there are two main assumptions of the parametric. One is normal and second is homogeneous. Okay. Now, how to find out the normality of the data? So there are three ways to find the normality of the data. One is through graphical display. Second method, distribution, means values of skewness and kurtosis. And third is normality test. It means if we want to find or estimate the normality of our data, then we have three methods to check the normality of the data. One is through graphical display. Graphical display means we will create histogram, or either histogram or PP or QQ plot. Okay. And second way, the skewness and kurtosis value, it should be between -1 to +1. If my data value between the -1 and +1 means skewness and kurtosis value between the -1 and +1, it means it is normal data. If my data value, it is outside this limit, means 2.8 or 15 point something, or minus 30.8, then data not normal. So condition of the normality is the skewness and kurtosis value between the -1 and +1. Okay. Now the normality, third is normality test with KS test. We perform the KS and Shapiro test. Through this test, the value of the p value should be greater than the p-value should be greater than point greater than 0.05. Okay. If value greater than 0.05, it means our data is normally distributed. If it is less than the 0.05, it means data not normal. So this is the condition of the normality. And second is homogeneity. Homogeneity means the dispersiveness of the data across the group, means two or more group. It the constant variance should be constant. And homogeneity we can find through the Levin test. So generally when we write a research paper or thesis, we give two value. For normality purpose, we produce the value of a KS test, and for homogeneity we give value of Levin test. So there are two values, means KS test for normality and Levin test for homogeneity. Okay. Now assessing the normality, how to assess whether our data normal or not. So there are three ways. I told you, one is graphical presentation. Through graph we can decide whether our data normally distributed or not. Second way, the value of skewness and kurtosis, its value between the -1 and +1. And third is KS test. So the first method to find the normality of the data, that is graphical display, means histogram or PP plot. So through histogram or PP plot we can check whether our data normally distributed or not. So here I am showing you the 3 days data, means the day 1 data, day 2 data, another day data, and this is third graph of third day data. Okay. Yesterday we have taken the case study of the hygiene condition of the particular place, and the biologist measured the hygiene condition, and 800 respondents were there. Hello. And then the normality, the day 1, here you can see the first graph left hand side. Here day 1 means the data more or less normally distributed. Here the curve, we superimpose this curve, normal curve, it is bell shaped. Bell shaped means ghanti ki shape mein you can see. So it is the normal data. Now the second case, here maximum concentration of the observation on left hand side. So it is not normally distributed, it is positive skewed. Our distribution is skewed in left hand side. And another data you can see, it is the positive skewness, because maximum observations in the left hand side. Second way to find whether our data normally distributed or not. That is the this PP plot. So through PP plot, we can find the whether our data normally distributed or not. The PP plot, the you can see here the diagonal line here diagonal. Okay, so in this all the observation lie on this diagonal. If our data, if all the observation lie on this diagonal, then our data normal. And if it is deviate from the this diagonal, so okay, please mute yourself. Okay. Please mute. Okay. Now, second is here the day to data. The deviation, the data deviate from this principal diagonal. The data is taking the shape. Okay, it is curve shape. So it is not, because it is deviating from this line. So that is why this data is not normal. And day 3 data you can see here. So again, it is deviate from the this principal diagonal and taking the shape of the curve like this. So all the observations should lie on the this particular type. Then we can say data is normal. But in the day 2 and day 3 data, it is not normal because the observation deviate from this line. Second method, the QQ plot. PP plot means probability plot, and QQ plot means quantile plot. Okay. Here in a quantile plot, so again it is same as the PP plot. So all the observations should lie on this diagonal, is this axis. But here it is more or less normal. So very few observation away from this diagonal you can see. But here it is completely taking the shape of curve. It is not normal. And here again the day 3 data, it is not normal. Second method to find whether our data normally distributed or not, the value of skewness and kurtosis. It should between the -1 to +1, and ideally it should be 0 for normal distribution purpose. And third method, the KS test, Kolmogorov-Simronov test. Through this test, the p-value should be greater than 0.05. It means data should non-significant here. So for assumptions purpose, normality and homogeneity, p-value should be greater than 0.05. So this is about the normality, and how to do in a SPSS. I will take one case study. Okay. Now assessing the homogeneity. So homogeneity basically tell us about the dispersiveness of the data, homogeneity of variance. Through this diagram, we can understand this.
Sir, can I ask one question now?
Yes.
No, I mean, you said that your data should be normal. Suppose you have completed the questionnaire, you have taken all the data, and you find that your data is not normal. So it means that all your effort has gone waste. What should you do?
No. Sir, it should not, our efforts not waste. So basically, if our data is not normal, then we have some other non-parametric test. I said today I will discuss two types of test. One is parametric test and second non-parametric test. Before applying any parametric test, we check the normality and homogeneity of our data. If my data not normal, not homogeneous, then we correct our data. So there are three methods to correcting the data. One, log transformation, second square root transformation, and third inverse transformation. If still my data doesn't correct, then we go for non-parametric test, which is equivalent to the parametric test. It means our efforts waste इसमें नहीं गए हैं, but we have another option, alternative to perform this statistical tool or checking the hypothesis, whether our hypothesis correct or not correct. Okay.
Sir, I have a question. Sir,
No,
I have a question.
can you please go to the previous slide?
Sir, I have a question.
Yes, 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 yes.
Sir, do I need to download SPSS now, or because yesterday I missed my class?
Sir, okay, no problem, sir. Sir, you can download your SPSS after this session also, or after this workshop, because it is 14 days the trial version you can download from the SPSS site. And after this workshop also, you can contact me. I have given my mobile number. So after this, if you need anything you want to do, if you find any problem, then you can contact me.
There are two versions I can see: SPSS Statistics and SPSS Modeler. So which one should I download?
Sir, SPSS.
No, SPSS Statistics or SPSS Modeler?
Sir, SPSS Statistics. Okay.
Okay, thank you, sir. Thank you, sir.
Okay, okay. My request to all the participants, please, I will take your all queries at the end of this session. Otherwise, it is not possible to cover many techniques, because I have to cover one independent sample, independent t-test, pair t-test, ANOVA, repeated measures ANOVA, Mann-Whitney test, Wilcoxon rank side, Friedman ANOVA, Kruskal-Wallis and chi-square test. So I will perform through SPSS all the 10 techniques. So please keep patience. After the this session, so we will take your queries. So we will means 10 to 15 or 15 minutes we can take your queries. Okay, because if I give the answer of each question, so it is not possible to cover the topic. Okay. KMO and Bartlett test, I did not mention here KMO. Okay, so I am just highlighting the homogeneity. What is homogeneity? Homogeneity basically the here we can see the two graph. One is homogeneous and another graph that is heterogeneous. There are two types of data. So here homogeneous means this is it's a case study. Ringing hours. The ringing hours means 0 to 70, and some there are some programs. One is Brixton Academy, Brighton, Bristol, means these are the music bands. So when some people went to this particular program, they observed ringing means 10 to 15 hours. Okay, तो उनको सुनाई दे रही है घंटी प्रोग्राम के बाद भी 10 to 15 hours तक. And in a second program again they can hear the ring 15 to 20. Here the range this to this is basically a range. Okay, when the range across the group, how many group? 1 group, 2 group, 3 group, 4 group, 5 group, 6 group, 7 group. When the range across the group is same, means constant, then we can say data is homogeneous. Okay, and in the case of the heterogeneous, the range, this range means 20 minus 15, 5 range, 25 minus 25 range, 35 minus 35. But when the range across the group same or constant, then data is homogeneous. If a range is not range is not, if we see the range is not the same, here the range is more. We can see here the range is 5, 15 minus 10. Okay, so the 15 and 10, this is 5. Second case, it more than 20 and 15. Okay, so range may be high. And in the third case, the range 30 minus 10, range is 20. So here range is increasing, but here range in the homogeneous data range same across the all the groups. Okay, now the color, this is okay. I can explain it again. So means this is the range. Range means this. The range. It is not writing. Yes. Yes. So the range, we can see here, this is the range. This is the range. Okay. Means this is range. So here range almost same. Here same, it is same and same. But the range you can see here, it is range is high in comparison to this. So data is not normal. And next, correcting the problem. So now your question, if your data, if our data not normal, not homogeneous, then what should we do? So we will correct our data. So there are three methods to correcting the data. One is through the log transformation. Through log transformation, we can correct our data. So this is the log transformation. So before log transformation, my data was skewed, but after the log transformation, we can make it normal, but not exactly normal. So second way is to correct the square root transformation. Before correcting the data, it was completely positive skewed, but when we apply the square root transformation, my data become the more or less normal data. So there are three methods. One is log transformation, square root transformation, inverse transformation. So I will perform all these techniques through SPSS, how to how to correct our data through log transformation, square root transformation, and inverse transformation. Next, the parametric and non-parametric test. Okay, so parametric and non-parametric test. So this basically today we will discuss parametric and non-parametric test. So what is the difference between the parametric and non-parametric? So here the two sample means two sample, and here you can see more than two sample. Okay, so what is the difference between two sample and more than sample? When we take two sample, means when we divide our sample into two categories, then it is known as the two sample. It means in our faculty development program, in this workshop, so all the participants, we can divide all the participants into the two categories, means female participants and male participants. Okay, so when we divide into the two category, so it is the two sample, and the first test, that is independent t-test. What does it mean, independent t-test? So independent t-test, the purpose of independent t-test to compare the two groups, okay, compare two groups. For example, if I want to know whether male participants, my hypothesis may be in a private sector, there is a significant difference between getting salary by male and female teachers. Okay, this is my simple hypothesis. So how to perform it, how to check it? So I can check this hypothesis through independent t-test, because there are two variable. One is salary, that is dependent variable, and independent variable means the two categories, means male teachers and female teachers. So how to check the hypothesis? So we will take 20 observations from the female participants and 20 observations from male participants, and then we will ask the salary of each 20 female teachers and each 20 male teachers, and we will take the mean value of female teachers and mean value of male teachers. So in an independent t-test, generally we compare two means. Here we are comparing two means, and then whether the mean, the difference is significant or not. If I say the one condition, 50,000 mean and 40,000 mean for another group. Second, 60,000 and 40,000. Third condition, 70,000 and 30,000. And fourth is 80,000 and 30,000. So which one is significant? Significant is 80 and 30. ज्यादा difference किसमें आ रहा है? इसमें. So the p value decide whether this difference is significant or not. Okay. So
can you repeat, sir? Can you please repeat, sir?
Okay. I am repeating, sir.
Sir, and we cannot see any slide of yours where you are mentioning values, probably the difference in significance value. All we can see is the chart which you're reflecting in the form of parametric and non-parametric. But that's all?
Yes. I have.
Okay.
Fine,
thanks.
Okay, I am showing this slide only. Okay, so here I am again repeating. When should we use the independent t-test? The purpose of the independent t-test for comparing the two group. For example, the y and x means we can divide our data into the two category. One is male, okay, and second is female. Okay, so this is my non-metric data. Non-metric means it is categorical data, and this is metric data. So I want to compare two means, whether my hypothesis, my null hypothesis is that there is no significant difference between getting salary by male and female teachers in a private sector. Okay, this is my hypothesis. There is no difference. But my alternate hypothesis is no, there is a significant difference between the male and female teachers, the salary getting by male and female teachers. So what will I do? I will take some observations from the male teachers, and for example, I am taking 20 observations from the male group and 20 observations from the female group. So I will take the mean value of salary getting by the male teachers and the mean salary getting by the female teachers. Okay. Now for example, this is the mean salary of the male teachers, 40,000. Okay, 40,000, and the female teachers salary, this is our 30,000. Okay, this is the difference. How much difference? This is a 10,000 difference. Whether this difference is significant or not, so we will not decide. P value decide. When we apply the independent t-test in SPSS, we will get the output. And p value means if p value less than 0.05, it means there is a significant difference. This difference is significant. So significant, we don't decide. The p value decide whether this difference significant or not. When we compare two means, always we will get the difference. Okay, you can compare. When you compare the two groups, always you will find the difference in the means. But whether this difference is significant or not. Okay, for example, this is. Yes, sir. Hello. Okay. So this, whether this difference is significant or not, so p value tell us, and p value should be less than the p value less than 0.0 to 0.05. Okay, then we can say the male teachers are getting higher salary than the female teacher. Second, so always the independent t-test used for comparing two groups, comparing two means. Okay, if we have more than two groups, means the one dependent variable, that is the one you can see here, right? Okay, so here we can see this is my independent variable and this one is y. Okay, so ANOVA, when should we use ANOVA? When we compare more than two categories, two groups. So the condition of the independent t-test, we can compare only the two groups. One group may be experimental group, another control group. One group rural, urban, private sector, urban sector. When we compare two groups, then we use independent t-test. In case we have more than two groups, then we use analysis of variance. Like, so if I conduct the test of relating to the research methodology to all the participants, and then I can divide, I can compare whether male participant obtained mean score higher than the female or not. So if I divide the two, my sample into two group, then, and group should be mutually exclusive. Okay, male participants and female. If I am comparing male and female, then I use independent t-test. If I divide my sample on the basis of education background, means science stream participants, commerce stream participants, and arts, means commerce and science and arts. So here I am comparing several means more than two means. So here I will use analysis of variance. Okay, so the analysis of variance means when we compare several means, so we can use an analysis of variance in physical sciences also, in medicine, medical science also we can use analysis of variance. Like the doctor give dose to patients 2.5 ml, 5 ml, and 7.5 ml, and after that he observed whether 2.5 ml effective or 5 ml dose effective or 7.5 ml. If 5 ml dose effective, then there is no need to give the 7.5 ml dose. Okay, so when we compare several group, then we use analysis of variance. Now the paired t-test. Paired t-test, when should we use the paired t-test? When we observe two times same respondents, like for example, in this workshop, I have some participants. So means before this particular program, I conduct the test and I give the marks to the all the participants, means participant number 1, 2, and so on. Okay, so means after this faculty development program, again I conduct the test, and then I want to know whether they received something from this workshop or not, their awareness level increase or not. So when same respondent observed two times, means before treatment and after treatment, or before experiment and after experiment, then we use paired t-test. Paired t-test, basically when we observe two times same respondent. In the case of the independent t-test, we divided our sample into two categories, male participants and female participants. But here I am not dividing in two categories. I am taking all the participants, and so before the treatment or experiment I am observing, and after this particular experiment. Okay, so means paired t-test we can use when we want to check the impact of the particular phenomena. Okay, so we can use this technique in science and social science research also, both. Now the another is repeated measures ANOVA. Repeated measures ANOVA means when same respondent repeatedly many times. Okay, means if you want to lose your weight, then you can join the training program. So this is your baseline weight, all the participants, and the weight after 1 month, weight after 2 months, weight after 3 months, means same respondent we are repeatedly we are measuring repeatedly same participants more than 2 times. In this case we use repeated measures ANOVA. Okay, so the difference between the independent and ANOVA is, in independent t-test we compare two means. Limitation is this: we can compare only two group, but in a ANOVA we can compare several means. And pair t-test, so we can observe 2 times, before treatment and after treatment. But if we want to measure repeatedly, then we can use the repeated measures ANOVA. So these are the parametric test. In a parametric test, before applying the parametric test, so we should check the normality, and homogeneity. So normality, for normality, the ks value, ks test value, the p value should be greater than 0.05, then we can say our data is normal. And live-in test, the p value, again it should be greater than 0.05. So before applying any test, either independent t-test, pair t-test, ANOVA, and repeated measures ANOVA, we estimate the normality and homogeneity of our data. If my data normal, and if my data normal and as well as homogeneous, then we can use independent t-test, pair t-test, ANOVA, repeated measures.
नहीं यार, ये फिर कनेक्ट नहीं हो पाएगा। अभी रांची का कॉल आया था तो
Excuse me, sir.
हेलो, हाँ,
हट गया था।
हेलो मैडम, ये आवाज आ रही है पीछे से कहीं से? प्लीज काजल जी, आपकी आवाज आ रही है
कर दिया
मैडम? जी जी, थैंक यू मैडम, थैंक यू। अब देखिए,
Participants, please mute yourself.
अब देखिए ये
Sir, I have a question.
मैडम, हाँ पूछिए।
Sir, can KMO and Bartlett's test be used to check the normality of the data?
नहीं मैडम, वो फैक्टर एनालिसिस में करते हैं। आप कहाँ इसमें ये चेक कर रहे हैं? वो फैक्टर एनालिसिस के लिए करते हैं मैडम। वो अभी हम जब परसों लेंगे ना फैक्टर एनालिसिस, उसमें हम चेक करेंगे बार्टलेट टेस्ट वाला, है ना। तो ये हो गया। ओके, सो
प्लीज ये पी वैल्यू कहाँ से आती है सर? पी वैल्यू
सर, पी वैल्यू अभी मैं एनालिसिस करूंगा, वहां से आएगी। अभी केवल इसकी थ्योरी बता रहा हूँ इन टेस्ट की। वेयर so I will take the case study and I will perform the independent t-test or ANOVA, pair t-test and repeated measures ANOVA. जो उसका output आएगा, then I will interpret कि what is p value. If p value less than 0.05, it means there is a significant impact. Okay, so I am just, हाँ, thank you sir. अब देखिए, मैं अभी केवल इसका थ्योरी बता रहा हूँ, then I will take the case study of each test. So I told you, before applying independent, paired ANOVA and repeated measures ANOVA, we check the normality and homogeneity of our data. Okay, now if our data not normal, not homogeneous, then what should we do? We correct our data. So there are 3 methods to correcting the data: through log transformation, square root transformation, and inverse transformation. If still my data does not correct, then we go for non-parametric test. Okay, so here we can see the equivalent of the independent t-test. It means why should we use independent t-test? What is the purpose of the independent t-test? The purpose of independent t-test to compare two means: rural, urban, male, female, public sector, private sector, experimental group, non-experimental group. Okay, so if for independent t-test, if my assumptions not fulfill, then we go equal to parametric test. This is non-parametric Mann-Whitney U test. So Mann-Whitney U test, it is a non-parametric test. Why are we using this test? Because my data not normal, not homogeneous. That is why we are using Mann-Whitney U test. Mann-Whitney U test also serve our purpose same as in independent t-test. Here in a Mann-Whitney U test, we compare two means, but here we will not compare two means. We will compare two ranks, mean rank. Okay, because the data in a non-parametric, it is ordinal data, and in a parametric data is a metric data. Okay, so in a non-parametric test, the Mann-Whitney U test basically compare two mean rank. Okay, and then if the difference is more, then we can say there is a significant difference between the two groups. So who will tell us whether this difference is significant or not? P value. Okay, so P value decides. Now second, pair t test. Pair t test we apply when we use experiment or treatment, means before treatment observation and after the treatment observations. So in this case we use pair t test. If our data not normal, not homogeneous, then we use equivalent to this, we use Wilcoxon signed rank test. So Wilcoxon signed rank test, it is same as the pair t test. Why are we using Wilcoxon signed rank test? Because my data not normal, not homogeneous. That is why we are using Wilcoxon signed rank test. Okay. Now third case, ANOVA. If my data not normal, not homogeneous, then we go for Kruskal-Wallis test. Kruskal-Wallis test, again it is comparing several mean ranks. Okay, so why am I using this Kruskal-Wallis test? Because my data not normal, my data not homogeneous. That is why we are using Kruskal-Wallis test. Okay, same as in case of repeated measures ANOVA. If assumptions do not fulfill, then we use Friedman ANOVA. So basically these are the tests. And now the independent t-test after this, parametric test. Okay, so parametric test we use for one variable, one sample t-test, and second we will perform here independent t-test, pair t-test, ANOVA, repeated measures ANOVA. Okay, so here I am taking the one sample t-test. This is my one sample t-test. So in this one sample t-test, I am taking only one variable because its name is one sample t-test. So my question is, in this case study, how many kilometer run tires? It's a tire company. In this case study, Company X Tires has launched a new brand of tires of cars and claims that under normal circumstances, the average life of tires is 40,000 kilometers. A retailer wants to test this claims and has taken a random sample of 10 tires. He tests the life of tires under normal circumstances. Means he is claiming the tire will run 40,000 kilometers. Whether he is right or not, so he took the 10 random samples. The first tire, this tire 36,000 kilometer run. Second 37,000, 41,000, 41,500. These are the observations. Okay. Now we check the whether his claim is right or wrong. Okay. So second independent t-test. So independent t-test, the data should be one dependent variable. It should be metric data, and independent variable means this question that we are using two question. One question should be dependent variable, should be metric form, and another question independent variable, it should be categorical, means independent variable should be non-metric or categorical. Okay, so if I want to apply the independent t-test, I should frame my question this way. The first question is, what is your gender? So either male or female. It is a mutually exclusive question. You will tick either one or two. And then second question is, how much salary are you drawing? This is the ratio scale question, because salary starts from 0. So your salary may be 10,000, 20,000, 50,000, 1 lakh. Okay. So before means this type of data, means the two variables we are using here, one should be metric form and another non-metric form performing the independent t-test. So this is the case study. Salary, the example to know whether the salary of male faculty members in a private institutions is equal to salary of female faculty members. Okay, so researcher collected data from 20 male and 20 female faculty members, and then we apply the independent t-test. My null hypothesis here, there is no significant difference between getting salary by male and female teachers, but my null alternate hypothesis says no, there is a significant difference between the salary getting by male and female teachers. Okay, so this is the another so here, sorry, this. Okay, so how to do it? So this there are two variable. One is dependent one is this is okay. So there are two variable, means two questions. One is dependent variable salary and another is non-metric data. So what will we do? So here we are taking 20 male teachers or 10. So in this case, we have 10 male teachers and 10 female teachers. So for example, the number one teacher salary is 40,000, another 50,000, someone salary 55, 43, and all these things. For example, the mean value of this is 50,000. Okay, and for I'm taking observation from the female teachers, the someone's salary is 45,000, 60,000, 65,000, 75,000, 10 observation, and the mean salary, that is the 60,000. Okay, so when we compare the two means, so always we find the difference, but whether this difference, the difference is 10, whether this is significant or not, who will tell us? P value. When we perform the independent t-test in SPSS, we will get the output, and P value decide whether the salary, the significant, whether this difference is significant or not. So through this data, we can see the female teachers are getting higher salary than male teachers. But can we generalize it? No, unless we get the result. Okay, if my result P value less than 0.05, then we can say yes, there is a significant difference between getting salary by female teachers in a private sector than male teachers. So this is about the independent t-test. So in an independent t-test, basically we compare two means. Okay, and second is the second pair t-test. Pair t-test means this is the manipulation or experiment or treatment before treatment and after treatment. So here for example, you want to apply, you want to reduce your weight. So there is a 1 month training program. So there are 10 participants, 1, 2, 3, 4, 5, and 10. Okay, this is 10 participants. So baseline weight means still you did not join the course. Now your weight is 75, 80, 73, and so on. And after the 1 month, this is the experiment or treatment period, then your weight is 72, 73, 68. So this is the difference. How much difference? The difference we can see here, 3, 7, or this. Whether this difference significant or not, who will tell us? This p value tell us. When we perform the pair t-test in SPSS, we will get the output. If a p value less than 0.05, it means there is a significant difference. It means this treatment is working. A p value greater than 0.05, it means this experiment is not working. Third, the next pair t-test. So this is the so we can take the example of the training program. So in this case study, the ABC University arranged a special faculty development program for one segment of teachers. The university wants to measure change in the attitude of its teacher after the faculty development program. Okay, so in this case study, so the before training program, teachers attitude score was this 25, 25, and the second teacher score out of 50, the score is 25, 35, 24, 16. Okay, after the faculty development program, the attitude increased the score of this 38, 45, 42, 32, 41, and so on. Whether this difference, because there is a difference, whether this difference significant or not, so p value decide, and p value, if p value less than 0.05, it means there is a significant difference. So the paired t-test basically we use when we observe 2 times same respondents we are observing 2 times, before treatment and after treatment. While in case of independent t-test, we divide our sample into 2 category, either rural, urban, public, private sector, or experimental, control. So here we compare the 2 means in independent t-test. And the next is analysis of variance. Analysis of variance, this is the store promotion. Here store promotion means this. So independent analysis of variance, there are 2 variables, this one dependent variable and another independent variable. So independent variable, there should be more than 2 level, more than 2 categories, means no promotion. So in this case study, we want to check the impact of promotion on sales. If we do not do any promotion, what would be our sale? If we use 20% discount, what would be the sale? If we give 40% discount, what would be our sale? So here the sale is depend on promotion. Okay, so when we compare more than 2 category, here there are 3 category, so we use analysis of variance. Next, the repeated measures ANOVA. When more than same participants, we observe more than 2 times. Here in the repeated measures ANOVA, so in this case study, the dietitian introduced new diet chart plan to reduce weight loss, and she took 15 women. 15 women want to reduce weight. the 15 and the 2-month diet program. This is the baseline weight. Baseline weight of first women means 75, another 73, and last women weight is 80. Okay, so after 1 month, what is the weight? 73, 70, and 78. After 2 months, the weight 70, 68, and 69. Okay, so here we are observing there are 15 participants. So we are observing more than 2 times. Repeatedly we are measuring the same respondent or women's. So this type study, it is related to the repeated measures ANOVA. Okay, but if we observe 2 times, then we use pair t-test. But when we observe more than 2 times, then we use repeated measures ANOVA. So I am taking these are the parametric test. Now I perform the independent, so one sample t-test. Okay, but before it I will check the normality and homogeneity of how to find the normality and homogeneity of our data. Okay, so in this case it's a case study of 800 participants. In this case study, yes sir, we will provide you the PPT and all material. Okay, so please do not worry about the material. So whatever I am discussing in this session, so we will provide you all the PPT. Okay, so there is no problem. Okay, now I was talking about the normality and homogeneity. How to find normality and homogeneity our data. Okay, so in this case study, 800 participants, they participated in a music festival or any program. So both male and female. So the biologist wants to know the hygiene condition of day 1, day 2, and day 3. Okay, so she given the questionnaire to all the 800 participants, and the score between the 0 to 4. Okay, so 0, 1, 2, 3, and 4. So anyone can give between 1 and 2, means the respondent has an option to give a score like 3.23. The first respondent given 0 means poor hygiene condition, and 4 means excellent hygiene condition. Okay, so if someone is giving in day 1, they stayed 3 days. Day 1, the first participants given the score.
Sir, screen not visible, sir.
Screen not visible. Okay.
No,
Okay.
Yes, sir.
It's visible in a very small format. It seems like it's
very small.
also a mobile. It might have gone.
Please.
No, sir, not visible.
ओके ओके ओके, मैं इसको फिर से देख रहा हूं सर. सर कैन यू सी इट?
Yes, sir.
Yes,
Yes,
yes.
Yes, sir.
Yes, sir. Yes, sir.
सर अभी इसको देख पा रहे हैं आप? एसपीएसएस फाइल को.
Yes, sir. Yes, sir.
ओके ओके, थैंक यू
Yes, sir.
ओके, थैंक यू. देखिए ये एसपीएसएस फाइल है, द जेंडर, डे 1, डे 2 एंड डे 3. ओके, सो हियर यू आई वाज टॉकिंग अबाउट द hygiene score. The zero means if someone is giving the zero, it means the poor condition, poor hygiene condition. And if someone giving near to 4, it means he observed or perceived good hygiene condition. Okay, so the total 800 participants. So the first participants given score 3.23. Okay, day 1, and day 2 he given 2.13, day 3 1.63. It means hygiene condition deteriorated during the time period, means after 2 days. Now here we want to check the normality and homogeneity of our data. How to check? These are the variables. So day 1, day 2, day 3. We can check normality and homogeneity only for metric data. Metric data. Metric means our data should be either interval or ratio scale data. Okay, then we can check the normality and homogeneity of our data. Now, how to check it? So first of all, so one by one, first of all, I will check normality, and then after I will check homogeneity. Okay, so although we can check for one command, but for explanation purpose I am I will perform 2 times. So analyze, how to check the normality? Analyze, descriptive statistics, and explore. Okay, analyze, descriptive statistics, and explore. Then day 1, I am selecting day 1 here. Okay, and day 2 and day 3. Okay, I have selected 3 variables, and then I move to statistics. By default it is giving descriptive. Descriptive, whenever you read the term descriptive, it means this term is talking about central tendency, measures of dispersion, and distribution. Distribution means skewness and kurtosis. Measures of dispersion means range, interquartile range, variance, and standard deviation. And central tendency means mean, median, and mode. It's a descriptive statistic. Yesterday I discussed about the descriptive statistics. When we perform the case test for normality, then by default we will get the value of descriptive statistics. So I told you there are 3 ways to find the normality of the data. One method is through graphical display. Graphical display means histogram and PP plot. PP plot means probability plot. Second way, value of skewness and kurtosis. Okay, and its value between -1 to +1. And third way to KS test, and its value should be greater than 0.05, means non-significant. Generally we report KS test in our research papers and thesis. So it is graphical display and skewness, kurtosis. It is just to get the idea about whether our data are normal distributed or not, but confirm, this test confirm whether our data normally distributed or not. Okay, so through skewness and kurtosis, so here descriptive statistics, through this descriptive statistics we will get the value of skewness and kurtosis. Okay, and graphical display, for next command, plot. When I click the plot, we will tick the, so here descriptive, by default it is tick descriptive, continue, and then plots. After plot, so here we can see histogram. Okay. And normality plots here. So the skewness and kurtosis we will get from this statistics. Okay, descriptive statistics. And histogram means graphical display we will get from this tick. And normality KS test we will get normality plots with test. So continue and then okay. I'm repeating again how to find the normality of our data. Analyze, descriptive statistics, and explore. So I am selecting all the three variables and transferring into dependent list. So I am pressing statistics, nothing to do because by default it is tick descriptive statistics. This table will give us skewness and kurtosis value, and then continue. Second, plots. I need histogram and KS test for normality. Okay, and then continue, and after this okay. Now my result. Oh, sorry, one mistake. What is the mistake? Here the hygiene condition for day, that is 120 observation, 122 observation, 122 observation. But my actual sample size was 800. Here in the first table you can see 800, 800, 800. Okay. So where is the wrong? कहां गलती की हमने? Now we check again. Analyze descriptive statistics. और ये why this result came? Because there are missing value day 2 and day 3. If you have missing value, then we should keep in mind how to perform the normality. How to perform normality? Analyze descriptive statistics, explore the options. Okay, first statistics means descriptive, second we tick plot, histogram and normality. Now we will tick options. If your data, if you have missing value, if you do not have missing value, then there is no problem. If you have missing value, then we will tick option, and here exclude, we will tick here exclude cases pairwise. Okay, if your data not missing, then earlier command was good, no problem. But in day 2 and day 3 there is a missing value, then we will tick this option, exclude cases pairwise, and then continue, and after that okay. Now we will get the another. This is my okay, this is now this descriptive statistics. It is descriptive.
Sir, kindly repeat this process of missing values.
Okay, sir. Again.
Sir, also in case of missing values, we can also fill the missing values now, like you did yesterday by calculating mean.
Yes. वो मैडम कर सकते हैं, but in case, मैं देखिए again repeat कर रहा हूँ कि in case you do not know whether you have missing value or not. Okay. So first of all, we should correct our data. We should impute all missing values. वहाँ पे missing values हमें भर देना चाहिए. But in case अगर कोई छूट गया है, then what should we do? Analyze descriptive statistics and explore. अगर missing value है, तब हमें we will tick options. Okay, and इस second वाला हमें we should tick it second option. Exclude cases pairwise. If you do not have missing value, then there is no need to do option button. We will not press it option button. By default, it is exclude cases list wise. But here we are looking the day 2 and day 3 missing values. So we will change here exclude cases pairwise and continue, and after continue okay. So we will get the result. And what is the result? This is my result. Now you can see in day 1 all the 800 participants were present. Okay, now you can see or check your data. We can check in day 1. So day one देखिए, start from one. One respondent one data, first did 3.23. अब देखिए, there is no missing value in the day one data. There is no missing value in the all the 800 score filled by the 800 respondents. Okay, day one everybody was present. There is no missing value. There is no missing value. But day two and day three, we can see the missing value. Day two and day three, there are missing values. These are the missing value. Okay, the one way we impute the missing value. Okay, we should impute missing value. Now, so what is the output? The output is in day one everybody was present, so there is no missing value. Day two only 268 were present, only 32.8% person were present, and day three only 122 was present. Okay, so the descriptive statistics. Now the descriptive statistics, this descriptive statistics, I told you descriptive statistics tell us about the central tendency, measures of dispersion and distribution, means skewness and kurtosis. So this is mean value 1.794 and 95% confidence interval, lower bound and upper bound, it's a limit. Okay, and 5% trimmed mean. This is trimmed mean means, so 5% trimmed mean ki it reduce, it cut the 5% cases, means two extreme 2.5% right hand side and 2.5 left hand side, and after this the mean value is 1.77, median value, variance, standard deviation, minimum. Now minimum is 0.02 and maximum is 20. It's a yesterday case study. It means the biologist give choice to the respondent to fill the questionnaire, and the option between the 0 to 4, means you can give 0, 1, 2, 3 or 4. But here the maximum value, that is 20. This is one outlier. Okay, and what is the value of skewness here? The value of skewness, and kurtosis, the skewness value 8.59 and kurtosis value the 169.567. So our data not normal because its value between -1 to +1, but here value is very high. So data not normal data, because this outlier change the whole descriptive statistics. This only one outlier out of the 800. And day two, so day two, there is no outlier. It is again outside the range because 1.081, so it is not normal. And day three data, we see the day three data 1.022, it is not normal. So we find the outlier. So outlier through histogram we cannot find the outlier. So through this box plot, we find the box plot. Where is box plot? The box plot is, this is the box plot. Okay, so in this box plot we identify the 672, the respondent number 672. This is the outlier. So in a box plot we can identify the outlier. Then we correct our data. So how to find the outlier? We go to 672. So how to identify outlier? So we go for edit, okay, and then go to case, edit, go to case, case number 672. So I am typing here 672 and then go. So we will get here this. So it is 20 point, the respondent number 672. The what is here 20. So I am correcting it and then I am applying again the the normality. Okay, analyze descriptive statistics and explore. Okay, and already so I can choose all the three and transfer here statistics. Again I am finding the case test, p-value, the descriptive statistics, continue, plots, I need histogram and normality plots, continue, options, because there is missing value day 2 and day 3, that is why I am taking second option, and then continue and then okay. And after okay, now we can see this is my the descriptive statistics. Now through descriptive statistic we find the value of skewness and kurtosis. So what is the value here? It is, this value is minus the skewness value minus 0.004 and kurtosis value minus 0.408. It means when means with outlier, the presence of the outlier, the skewness and kurtosis value was different. When we remove the outlier or correct the outlier, now this value is decrease. Earlier it was 8 point something and 167 and something. Okay, earlier the value of skewness and
कैसे ठीक किया सर? आउटलायर में क्या किया? प्लीज थोड़ा सा आउटलायर कैसे ठीक किया?
अभी मैं बताता हूं सर फिर से. So sir देखिए, so earlier we found how to correct the outlier. So through previous this. Okay, so in the previous slide you can see we identify the 670, the outlier. Which one? The 672 respondent number 1, the outlier, and he put it 20. Okay, the score he given 20. Instead of between 0 to 4, he given the 20. So how do we identify the outlier? So we go to here, sir, edit, and then go to case. Okay, we know the case number 672. Go to case, and then here we will write 672. Okay, I am writing here 672 and go. And after go, we find this. Earlier it was 20. Okay, the option was between 0 to 4, but by mistake it was written here 20. So I am correcting here. I am correcting it. Okay, now it is 2. So this is the way to identify the particular case, and there are two ways. Either you remove this case or the value between the particular range, जो range हमने उसका दिया था. Okay. Now the output, I am finding the skewness and kurtosis. So through descriptive statistics, day 1 data is it is normally distributed because it is between the -1 and +1. The -1 and +1.
Excuse me, sir.
Yes, yes.
Sir, please repeat. Actually, I lost the connection in between. Can you please repeat? Can you please?
मैडम
I lost the connection.
ठीक है क्या रिपीट करना है मैडम बताइए.
Just before you said the things, we were on their edit and case 672.
Okay. I am repeating.
Thank you so much.
Thank you, madam. Okay. So, madam, how to find the particular outlier? So, my outlier was 672 case. Okay. So, how to identify? Go to edit and then go to case. Okay, edit, go to case, and then we will write here 672, and then press go. After go, we will find this 672. Now I have corrected it. Earlier it was 20. Okay, now we will okay, I have corrected it. Okay, earlier it was the value 20 like this. So मैंने इसको ठीक कर दिया. Now the output. What is the output? After correcting it, so before, when I did not correct it, the value of skewness and kurtosis was very high, but now the value of skewness and kurtosis very low value, and it is between the -1 and +1. It means there are three ways to correct the check the normality. The first way, the first method, the descriptive statistics. Second, graphical method. So in a day 1, the data is normal distributed. Day 2, 1.081, and kurtosis value 0.748. So it is not normal. Day 3, 1.022, it is outside the range. Okay. And third method is the test of normality. So its value should be less or greater than 0.05. So in this test of case test, the significance value, significance basically it is p value. And what is the p value? It is greater than 0.05. What is p value? P value is 0.193. Okay, so it is not significant and desirable for us for checking the normality. It means day 1 data normal. This data normal because its p value greater than 0.05. Day 2, it is less than 0.05, p value 0.00. It is not significant. It is significant. That is why it is not normal. And third data, again its value, p value less than 0.05, and the p value 0.00, again it is less than 0.05. That is why data not normal. Okay, so through descriptive statistics means value of skewness and kurtosis, day 1 data was the normal, and through case test it is normal, but day 2 and day 3 data not normal. And then we see the graph, histogram and PP plot. So through histogram we can see I am double clicking it and I am superimposing the normal curve. Okay, so elements and show distribution curve. If you want to superimpose normal curve, how will you do it? So double click this graph and then go to elements and show distribution curve. So we can find the normal distribution curve on this data. So it is more or less normally distributed. Okay, and this QK plot, again all the observation lie on this axis, so it is normal, and it is day 2 data. Now day 2, it is not normally distributed. So I want to superimpose normal curve, elements, and then show distribution curve, and then close, and after close, okay. So it is positively skewed. Okay, and our data descriptive statistics also telling the skewness of the data positive, 1.081 positive value. Okay, now day 3 graph and the QK plot, again it is taking the shape of curve. It is curve shape, है ना? It's इसकी shape curve की तरह है, so that is why it is not normal. And day 3 data, this is the graph of histogram, the element, show distribution curve, and then this. Now we can see again it is not normally distribution. Now how to check the homogeneity. So homogeneity, how to perform? So we can perform normality and homogeneity in one click. How do we do this? Analyze, descriptive statistics, explore. Same way. Analyze, descriptive statistics, and explore. So I am transferring all the three variables into the dependent list and gender of participants. I am changing one thing here. I am transferring gender of participant here, factor list. And then I am clicking statistics. By default, it is descriptive statistics, nothing to do here, and simply continue. Then plots, I am clicking this. I need histogram or normality plot, or I don't need histogram. I need only case test and live-in test value. Normality plots and untransformed. For homogeneity purpose, for homogeneity live-in test, we will tick this untransformed. For case test, we will tick here, and for live-in test, I am ticking untransformed, and then continue. So I don't need descriptive statistics. That is why I am untick it. Okay, I need only the normality test, means case test for normality, live-in homogeneity for live-in test, and continue, and options again, because missing value day 2 and day 3 there are missing value. That is why I am taking here, and then continue, and after continue, okay. And what is the value? This is the value. Now where is the value? This, yes, this one is value. So here we can see the normality day 1 for male participants. So here two normality, one for male participants and another for female participants. For day 2, two normality, one for male, one for female. For one for male, one for female. So what is whether data normal for male participants or not? We can see this. Yes, because p value greater than 0.05, it is more than 5%, means 20%. Okay, so for male participant it is normal. For female, no, it is not normal, because p value less than 0.05. Again, it is not normal, it is not normal, it is normal. This is normal. P value greater than 0.05 means 6.6%. It is 5%. So greater than 5% means 6.6. But for female, it is not normal. So data is not normal, because for normality, every data should be normal. If one data not normal, then we will say our data not normally distributed. Okay. Now we check the homogeneity. So homogeneity we check through this live-in test. This is live-in statistics. Okay, what is the value of live-in statistics? This significance. This is the p value, and p value greater than p value should be greater than 0.05, but it is less than 0.05 because p value is 0.03. It means 3%, less than 5%. So data not normal. We take only this value based on mean. We do not take median and trimmed mean. So for day 2, it is not normal because its value very less, 0.003. For day 3, data is not normal. So data not normal and not homogeneous. Now, how to correct our data? Now we will correct our data by using 3 methods: log transformation, square root transformation, and inverse transformation. So, the how to transform our data. Okay, so here I am using the log transformation. So how to do it? Okay, I am performing this. Okay. So, okay, प्लीज किसी का नेटवर्क इशू शायद है, नाम मुझे ध्यान नहीं आ रहा, मैसेज लिखा है किसी ने, खैर ओके चलिए. हाउ टू करेक्ट अवर डेटा, ट्रांसफॉर्म. आई एम यूजिंग लॉग ट्रांसफॉर्मेशन. compute variable log transformation. I am writing here log 2. Log 2 means I am correcting day 2 data. Okay, and then I am copy and paste it, type and this, and then continue, and after continue, okay. So how to do log transformation? So I am taking all, okay, and log 10. I am searching here log 10, log 10, log 10. This is log 10, log 10. This one is log 10. Okay. Now day 2. I am transferring here. I am writing here +1. Why? Why did I write here +1? Because my options were 0 to 4, means between 0 to 4. If someone given the value 0, then log 0, what would be the value of log 0? Infinite. Okay. So if my options were between 1 and 5, then there is no need to add +1. So that is why I have added here day 2 +1 and then okay. This is the one way to transform the data, and we will find this table or this variable. This is the log 2. Second way to find convert the square root. So
सर रिपीट प्लीज, एक मिनट रिपीट कर लो इसको ही सर.
किसको सर?
सिर्फ की इसको रिपीट करो
सर. मैं रिपीट कर दूंगा, वैसे इसकी रिकॉर्डिंग भी मिलेगी आपको, ठीक है ना? मैं रिपीट कर रहा हूँ आपको, कोई
जस्ट रिपीट द प्रोसेस ऑफ एडिंग +1.
बिल्कुल बिल्कुल बिल्कुल. अभी मैं फिर से कर रहा हूँ मैडम, वैसे रिकॉर्डिंग भी है, अगर कोई चीज छूट जाएगी तो मिल जाएगी आपको, कोई बात नहीं, मैं रिपीट कर रहा हूँ. देखिए, द ट्रांसफॉर्म एंड कंप्यूट वेरिएबल. ओके, compute variable. So I am writing here log 2, log 2, log 2. Okay, log 2 means day 2. I am converting day 2 data. So I copy and paste here, paste, and then continue. Now I will search log. So I will take here first all and then log 2. Log 2, I am searching log 10. Yes, this is log 10. Okay, and then I am converting this day 2 data and select and transfer here and just write +1. Okay, you just simply write +1 and then okay. So you will get the log 2. Log transformation. Second is square root transformation. So square root transformation means transform, compute variable. So reset. So I am writing here sqrt, square root or sqrt, and copy and paste, type and label, and I am pasting here and then continue. Now I search square root. So I am clicking all, and then I am searching square root s q square root. This is square root. Okay, this is square root, sqrt, square root, and I am just clicking here, and then it will display here. It is displaying here. So I am selecting it, and hygiene 2. Okay, this is hygiene 2, and then continue. I'm transferring here. So in a square root, there is no need to add +1 value. Okay, and then okay, and after okay, you can see the new column. This is square root. And third is inverse root transformation. How do we do it? Transform, compute variable, and reset ins2 inverse. Okay, and copy it and type and label, paste, and continue. So inverse means it is 1 by this, 1 by, but I will not transfer 1 by day 2, because if anyone put the value 0, so 1 by 0 means infinite. Okay, that is why I will add +1. Day 2, I am transferring day 2 and writing +1 and bracket close. Okay, this is inverse, and then continue. Okay, and after okay, we will get the another column. So this is the inverse. Okay, this is the inverse. So there are, I have corrected through log transformation, square root transformation, and inverse root transformation. Now I check whether my data normal distributed or not. So I just want to check through the graph. So graphs, chart builder, and then okay, and after okay, the histogram. I am selecting is histogram. This is histogram, and double click this. Okay, now I am transferring log 2 here, x-axis, and then histogram %. So element properties, I am taking element properties and changing it histogram %, and display normal curve. I am superimposing normal curve and ticking it. Okay, and then apply, and then close, and after close, okay. Now what would be my graph is this. Earlier the shape of graph was not, earlier the shape of the graph was, I am showing you the before. Yes, before log transformation shape was this, and after log transformation the shape of the graph is this. Now now you can see. Okay, now we check through square root, chart graph, chart builder, okay, and reset, and then square root. But before it, I will select histogram. This is histogram, double click, and I'm transferring square root into x-axis, and then histogram %, and then display normal curve, and apply, and after apply, okay, and now you can see the graph. So it is more correct. Now you can see the data is more normal in comparison to this log transformation. Now we use another method, inverse root transformation. Graphs, chart builder, and then okay, and after okay, reset. I am selecting simple histogram and inverse ins2 into the x-axis, and I'm changing histogram, percent, display normal curve, apply, and then close, and then okay. So this is my graph. So these are the way to how to correct our data. So here we can see the square root transformation is good in comparison to the log and inverse root transformation. Okay, now I am taking the one sample t-test. Okay, now I am using the parametric test. So I am taking one sample t-test, independent sample, independent t-test, pair t-test, ANOVA, repeated measures ANOVA. So I am performing 5 parametric tests. Okay. Now first test is the first test, one sample t-test. In this,
Sir, one question.
yes, sir.
Quickly, after the transformation, won't we actually go back and again do the test, Livon test and to ensure?
Yes, you can do, sir. Yes, same procedure we apply.
Okay.
So one more question. Sir, how do we decide which method of transformation we should use? Log, square root, or inverse?
नहीं, जिसमें वैल्यू हमारी ठीक आ जाए. If you think the log transformation में वैल्यू ठीक आ रही है, then you can use log transformation. If you think my value good for square root transformation, then you can choose the square root transformation. So basically these transformation we use to reduce the skewness when our data is positively or negatively skewed. So through log transformation, square root transformation, या inverse, so you can use any method. Okay.
Thank you,
Now,
sir.
Excuse me, sir.
Yes, sir. Yes, sir.
Sir, like we saw in case of when we were taking log, and after taking log transformation, the data was a little bit normalized, not fully, sir. So can we do, sir, again log of this log 2 table, log 2 data?
नहीं, उसमें फिर चेंज नहीं आएगा सर, वैसा ही रहेगा.
Okay. So we can take only one time. We can transfer only one time.
सर देखिए, हमको अपने डेटा को जबरदस्ती नहीं करना है कि उसको कन्वर्ट करना ही है. अगर मान लीजिए नहीं होता है, देन वी हैव अनदर इक्विवेलेंट टेस्ट ऑफ नॉन पैरामेट्रिक टेस्ट. ऐसा नहीं है कि हम जबरदस्ती उसको नॉर्मल, उस डेटा को ट्रांसफॉर्म करके नॉर्मल और होमोजीनियस बनाएं. अगर वो नहीं आ रहा है, then equivalent of parametric test we use non parametric test. Okay.
Okay, so, sir. But sir, after you have done, sir, and normal आ गया हमारा data, and after normal, what about homogeneity, sir? Homogeneity वाला जो variance था, sir, वो अभी भी रहेगा या उसको भी दोबारा कोई transformation method है उसके लिए भी?
नहीं सर, उसके लिए कुछ नहीं है. अगर डेटा देखिए, if your data normal but not homogeneous, or your data homogeneous but not normal, then you will not use parametric test. Means both the conditions should be fulfilled. Your data should be normal and as well as homogeneous. If your data, हाँ,
अभी सर आपने डाटा को नॉर्मल कर दिया स्क्वायर रूट मेथड से, और हम अभी आप फर्दर टेस्ट लगा रहे हैं, तो क्या हमें होमोजेनिटी एटलीस्ट चेक नहीं करनी चाहिए कि वो भी नॉर्मल हुई है नहीं हुई है ये टेस्ट लगाने के लिए?
वो तो सर आप जब डेस्क्रिप्टिव स्टैटिस्टिक्स के नॉर्मलिटी और नॉर्मलिटी थ्रू केस टेस्ट एंड लिव इन टेस्ट फॉर होमोजेनिटी वो आप निकालेंगे ही, ठीक है ना, इसी डेटा से, इसी के. इफ अगर आफ्टर कन्वर्टिंग और ट्रांसफॉर्मिंग डेटा, अगर आपका डेटा नॉर्मल एंड होमोजीनियस है, देन देयर इज नो प्रॉब्लम. अगर डेटा नॉर्मल है और होमोजीनियस नहीं है, देन वी गो फॉर नॉन पैरामेट्रिक टेस्ट.
ओके सर, थैंक यू सर.
Okay. Now, so I'm taking the non-parametric parametric test. This is so, dear participants, I will take your query at the end of this session because I have to perform 10 tests. So, अब देखिए, the in this case study, the manufacturer, he is claiming that my tire will run 40,000 kilometer. So इसकी जो हाइपोथेसिस है, it means null hypothesis, the population mean or this कि the population mean यहाँ पर कितना है 40,000. This is 40,000. Okay, and alternate hypothesis mu does not equal to this sample mean. Okay, now he is saying the tire will run 40,000 kilometer. If p value greater than 0.05, it means जो ये क्लेम कर रहा है वो ठीक कर रहा है. If p value less than 0.05, it means इसका क्लेम झूठा है. It is false commitment. Okay, so we will check p value. So how to perform the one sample t-test in SPSS? So we go for analyze. So analyze and then compare means and one sample t-test. Analyze, compare means, one sample t-test. Okay, and after that what will we do? There are number of tires and life of tires. So I am selecting life of tires and transferring in this box test variable. And what is the test value? Test value is 40,000. So I am writing here 40,000. Okay, and then option nothing to do, just simply okay. I'm repeating again how to conduct one sample t-test. Analyze, compare means, one sample t-test. Okay, and then I'm transferring my continuous variable, test variable, and the test value, the 40,000. So I am writing here 40,000 and then okay. So what is my result? This is my result. So what is the p value? So p value here. So what is the mean value? So my population mean was 40,000 and sample mean, that is 40,100. It is different but not significant. Who will tell us whether this difference significant or not? This p value. Here p value. What is the p value? It is greater than 0.05. It is greater than 0.05 means its value, p value 0.885. My null hypothesis was the population mean equal to sample mean, and alternate hypothesis, the population mean does not equal to sample mean. So here he is claiming his claim was good, right? He is claiming right. Okay, so this is about the one sample t-test. Now I am taking the case study of the second. The case is independent t-test. So independent t-test, I have data of male and female teachers data. So in this case study, there are two variables. One is y and another is x. Okay, x means it is non-metric data, nominal data means male and female, and y, that is metric data. What is this metric data? Salary. Okay, now here I am comparing in an independent t-test. So what is my hypothesis? My null hypothesis is there is no significant difference between getting salary by male and female teachers in a private sector. There is no significant difference. But alternative hypothesis is there is a significant difference between getting salary by male and female teachers. So who will decide whether the difference significant or not? This p value. If p value less than 0.05, then we will say there is a significant difference between male and female salary in a private sector. Okay, so how to perform it? So we perform it through decay. Now analyze and compare means this is independent sample t-test. This is independent sample t-test, or and so the what is your gender? So there are two categories. One for I am transferring gender categorical variable into grouping, and define variable I am picking it define variable, and one group 1 coded 1 and group 2 coded 2. Okay, you can see, and then continue, and I am transferring salary of teachers here. So it is very simple to perform independent sample t-test. I am performing again. So analyze, compare means independent sample t-test. And what is your gender? I am transferring grouping variable, define group, group 1. There are two categories, one for male and two for female. And then continue, salary of teacher here, and then okay. Now what is my result? My result, this is my result. So here the male salary, that the mean male salary, the 49,000, the male mean salary 49,900, and female mean salary 39,400. We should keep in mind when we compare two groups, always we will get the different value, always. But whether this difference is significant or not, who will tell us? P value. So what is our P value? So here now we can see three things. This is T value, it is 4.08, and P value, this is 0.00, so less than 0.05. So it means there is a significant difference between male and female teachers. Okay, now we can conclude we can generalize male teachers got more salary than the female teachers in a private sectors. We can generalize. Okay, now another test, the paired t-test.
Excuse me, sir.
Yes.
Sir, in this case, the observations of male and female both are 20/20. Should it be equal always whenever we try this test?
Madam, you can take different sample size. Means because we are taking mean value, you can take 20 male teacher salary and 50 female teachers. Okay, because we are taking meal. So there is no. Okay. Now I am taking the paired t-test. This is paired t-test. So this case yesterday related to the attitude. So the 20 teachers here, 20 teachers. So the ABC University sent 20 teachers to joining a particular faculty development program, and then after the faculty development program, the organization thinks that after the faculty development program they can be motivated and they can write the good research paper, and they can do good work. Okay, now this is the case study. So before treatment means 20 teachers. So before treatment, the treatment is faculty development program, FDP. Okay, this is the treatment. So before treatment, the observation of number one teacher. So there are some teachers. The number one teacher score is 22, 22, 26. These are the score. These are score 22, 26, and so on. And after the faculty development program, the score, same respondent score increase 35, 36, and this. Okay. So this is about the pair t-test. When we observe two times same respondent, when we observed same respondent two times, then we use paired t-test. Okay. Now how to do it, how to perform? So analyze, and then descript compare means an independent sample t-test. Okay, sorry, paired t-test. Again I am repeating, analyze, compare means and paired sample t-test. Now I am transferring before faculty development program and after faculty development program both, and then okay. So after okay, what is the output? This is my output. Now the before faculty development program, the mean score of the 20 teacher before FDP, the score was 24.75, and after the faculty development program, the attitude score, mean score increased 33.25. This is 30.33. It means there is a difference. I'm not saying significant. So who will say this difference is significant or not? P value. Now we check the P value. So last three column, we interpret last three column, and what is the P value? Here P value is 0.00. Okay, means P value less than 0.05. It means there is a significant impact of faculty development program on the teachers. Next case study, ANOVA, related to ANOVA. ANOVA. Okay. So in this case study, we can see the 15 departmental store, 5 departmental store. In 5 departmental store, we are not using any promotion. 5 departmental store, we are using medium promotion, and another 5 departmental store, we are using high promotion. Okay. So in this case study, there are 5 departmental store. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. No promotion. कोई प्रमोशन हमने नहीं किया, और इनकी सेल देख रहे हैं. इस डिपार्टमेंटल स्टोर सेल 3 lakh. Okay. Second 2.5 lakh, 2 lakh, 1.5 lakh, 3.5 lakhs. Okay. These are the sale of when we are not using no promotion. Now the 5 outlets, 1, 2, 3, 4, 1, 2, 3, 4, 5. And we are giving medium promotion, means we are giving 20% discount. Okay. So what is the sale? Now sale of first retail outlet 5 lakh, then 5.5 or 4 lakh 50,000. These are the sale. And third 5 outlets, retail outlet, we are giving the 40% discount. So 1, 2, 3, 4, 5. Okay. The sale of this 7 lakh, 5.5, 5 lakh, it means it is increasing when we compare. So whether this difference, whether sales promotion is impacting or not, so we will compare it. So how to perform analysis of variance in SPSS? So here the analyze and then compare means analysis of variance, one way ANOVA. Okay, one way ANOVA. So one way ANOVA. one way ANOVA. फिर से रिपीट कर रहा हूं. ओके, आई एम रिपीटिंग. एनालाइज, कंपेयर मींस वन वे ANOVA. ओके, and then the sales dependent variable, sales promotion independent variable, I'm transferring it factor. And then contrast, nothing to do here. Post hoc analysis, 18 test here, so I'm selecting only one, Bonferroni test. So Bonferroni test, this is the Bonferroni test I'm using. I'm picking Bonferroni and then continue, then options, descriptive statistics, homogeneity of variance test, and continue. Okay, I'm repeating again how to perform ANOVA. Analyze, compare means one way ANOVA. Okay, one way ANOVA. And then sales, it is dependent variable. I'm transferring here. Sales promotion, independent variable. Factor, contrast, nothing to do. Post hoc analysis, Bonferroni. And then continue. What is the purpose of Bonferroni? I will explain in output. And then options, descriptive, homogeneity of variance, and then continue. And then okay. Now I am showing you the output. So this is output. So in this output we can see when there is no promotion, the mean is 2,50,000. When we are using 20% of medium promotion, the mean is 4,50,000. When we use a high promotion, then the mean is 560. Okay, it means this is different. All the values are different, not same. Okay, so now we want to check whether this difference is significant or not. So through ANOVA table, this ANOVA table, this p value tell us whether this difference is significant or not. If its p value less than 0.05, it means there is a significant impact of sales promotion on sales. It means when we introduce discounts, then sale increases. But we do not know whether medium promotion improve the sale or high promotion. Okay, so that is why we use post hoc analysis test. Now this is post hoc analysis test. It means we will compare. So we will create three groups. Means there are three pairs. Pair 1, no promotion with medium promotion. Second pair, no promotion with high promotion. And third is medium promotion to high promotion. Although we should check only no promotion medium and no promotion of high promotion. Okay, now what is the value? Now no promotion in medium, this is no promotion in medium. What is the significance value? This 0.09. P value less than 0.05. It means there is a significant impact. If you give 20% discount, your sale significantly increase, and we have seen the sale before the promotion, mean sale was 2,50,000, and when we introduce 20% discount, sale increase, mean sale increase. So this difference is significant. Now the no promotion and high promotion, if we give the 40% discount, what is the result? So no promotion and high promotion. So again, its value, its value, p value less than 0.05. It means the 40% discount also increases the sales or significantly, because when there is no promotion, the sale was 2,50,000, and when we use 40% discount, the sale increase 250 to 5,60,000. So there is a significant impact. And third is medium to high. If we give 20% discount, it means if it is significant, then if we give more than 20%, like 25%, 30%, naturally it will also increase the sale. So medium promotion and high promotion. So here we can see whether it is significant or not, but here we can see this 20% additional, it is not giving the significant impact. Okay, so we interpret only, we report two results. This, when we give the 20% discount, sale significantly increase, and when we increase 40% discount, 40% or high promotion, so sale is significantly increase. Now we see the repeated measures case study. The case study is this. Okay, so in this case study, these are there are weight start. It means there are 10 participants. Baseline weight of the 10 participants, the 63, 62, 65, 107, these are the weights. Okay, and in this training program, after 1 month, the weight it is increasing. Instead of reduce, the weight is after 1 month 65.38, and after 2 months 81. So whether this training program significant or not, so we will check it. Okay, so it's a case of a repeated measures ANOVA, because we are measuring 10 participants more than 2 times. Means baseline, after 1 month, after 2 months. So here we will use the repeated measures ANOVA. How to perform repeated measures ANOVA? So I think through data we can see the data is not reducing, but it is increasing. But some participant weight is decreasing. Its weight not decreasing. It is increasing, decreasing. It is decreasing. So whether the training program success or not, so through data we can say it is not successful, but we cannot say now unless we test through repeated measures ANOVA. And p value tell us, if p value greater than 0.05, it means this training program not effective. So how to perform repeated measures ANOVA? Analyze and general linear model and repeated measures. Here analyze, general linear model and repeated measures. Then, so factor, I am writing here weight, WEIGST. Okay, so how many level? 3 levels: baseline, after 1 month, and after 2 months, and I am add. Okay, and then define. I'm pressing define. Now I am selecting all the 3 variables and transferring here. The transferring here, and then model, nothing to do here, continue, simple, contrast. Yes, I am changing it. Repeated, repeated, and change, and then continue. Okay, then plots. I do not need plots. Post hoc analysis, here we cannot do. Then save, I don't need to save right now. Options. Okay, then overall I am selecting it and transferring here. Display means weight, transferring here. Both the variable I have transferred here. Display means for. And then I am taking compare main effects. I am selecting CDAC. Okay, and then descriptive statistics, estimates of effect size, transformation metrics, and then continue, and then okay. I'm repeating again how to perform repeated measures ANOVA. Analyzed general linear model, repeated measures. Okay, and then I am writing here weight, GST, and how many level? 3. So I am writing here 3, and then add. After add, define. I am selecting all the 3 variables and transferring here. Model. Okay, continue. Then contrast. I am changing repeated. I am selecting repeated and then change. Continue. Plots. Nothing to do here. Post hoc, I am taking only options. Transferring both the variables. And then taking compare main effects. And then CDAC. And after that, descriptive statistics, estimate effect size, transformation metrics, and then continue. Okay. After that, okay. So what is the output? So we will check only p-value, whether p-value is significant or not. So here the p-value, we can see here the multivariate test. So p-value, it is greater than 0.05. It is 0.931. Okay. So again, here we can see the p-value. All the p-values are greater than 0.05. So it means this training program, they not effective for reducing the weights of participants. Now I am using the non-parametric test. So I am so non-parametric test means when assumptions of the parametric tests do not fulfill, then we use Mann-Whitney U-test. The first test is Mann-Whitney U-test. We see the case study of this test. We will provide you all the PPT and all the data so you can practice it. So non-parametric test, these are the tests. Wilcoxon rank sign test, one sample for the another Mann-Whitney U-test, 2 independent sample. Wilcoxon rank sign test for the 2 dependent sample. Kruskal-Wallis test. So one by one I am taking the test. 1 sample t-test. So in this case study, just to go through the case study. In this case study, State Bank of India manager indicates that the median number of saving account customer per day is 53. Okay. A clerk from the same branch claims that it was more than 53. It means the number of clients visit per day 53. Now he has taken the sample random whether his claim is right or not. Okay, so we will check it through the one sample, the Wilcoxon-Rankin test. Where is my data? Data for this one sample. This is the data. Okay, so the day 1 50 clients visited bank, day 2 55, 54. He is claiming the daily visit 53. Okay, so how to perform? Analyze. I am performing non-parametric test. Analyze non-parametric and one sample. This is the root. Okay, you can see it. I am repeating again. Analyze non-parametric test, legacy dialogues, and one sample case test. Okay, now this customer and transferring here, test of distribution normal or descriptive statistics and continue. Okay, whether it is significant or not. What is the p value?
Please repeat sir, एक मिनट repeat कर दो sir please.
सर मैं repeat कर रहा हूँ दोबारा से, कोई problem नहीं है. One sample. Okay. Sir, there are two ways to perform it. Analyze non-parametric test or one sample test. So we can perform it here also, but I am not performing first. Now I am performing analyze non-parametric and legacy dialogues and one sample case test. Now you can see it, sir. Okay. Whether his claim is right or not, so we want to say. Is it clear, sir? So analyze non-parametric legacy dialogues and one sample case test. Now I am transferring customers into test variables and then okay. So what is the value? So here the value is the greater than 0.05. So we can see here the value, it is this. Okay, means the null hypothesis was, he was saying the 53 means population mean and this. Okay, the 53 visit daily into the banks, and null hypothesis, no, his claim was wrong. But here the p value greater than 0.05, it means whatever the clerk was saying, he was right, because the claim was not significant different. Now we perform Mann-Whitney U test. So this is my Mann-Whitney U test. Okay, so in a Mann-Whitney U test, it's a parametric non-parametric test. So here there are two groups. One group means the ecstasy tablet. So the doctor selected two groups. So one group, the doctor is giving the tablet for depression patient. The person who are depressed, the doctor is giving the ecstasy tablet, and rest of the 10 patient, the doctor is saying you take the alcohol. Okay, so there are two groups, and Saturday night the doctor giving the ecstasy tablet to 10 patients and measured the depression score next day Sunday. Okay, and continuously 3 days the doctor given the tablet, and another day Wednesday again check their depression level. And for the people 10 participants, the doctor giving the alcohol and next day check the depression. So here doctor wants to know whether tablet work or alcohol work for reducing the depression level. Okay, now we can check because it is non-parametric test, so we can check the normality and homogeneity of this. So analyze, descriptive statistics, explore. I am checking normality and homogeneity of this data. Analyze, descriptive statistics, explore. So both the score I am taking, although okay, I am taking only 1 day score, na? So the dependent and type of drug, that is factor, and then statistics, sorry, not explore, analyze, descriptive statistics, yes, explore. Okay, so the Sunday and the types of drug, here statistics, nothing to do. I need only case test and live-in test. Case test for I'm checking the normality and as well as homogeneity. So normality for live-in test and homogeneity for live-in test. Okay, and continue.
But why you are doing that? Because in non-parametric test.
Yes, because it is so I want to, although before estimating the parametric test we check the normality and homogeneity. So in earlier case I did not check the normality and homogeneity because we have checked how to check the how to estimate the normality and homogeneity. But in parametric test I am checking whether data is this normal or not. Okay, although there is no need for
non-parametric test. So
okay,
test we are doing because
yes, you are right, but I am checking although I am assuming that it is not I am assuming that the data may be normal and homogeneous. Okay,
sir.
Okay, I'm just checking although there is no need for checking the homogeneity and normality in non-parametric check. We check normality and homogeneity in parametric test. Okay, so I am checking whether the data normally distributed or not. So I am okay, and then so yes, this is okay. Now you can see the data p value, it is less than 0.05, the data not normal. For alcohol group it is normal, and homogeneous, again data is homogeneous. It means data exactly data not normal but homogeneous. That is why we are using non-parametric test. So if you are using the non-parametric test, you should give or you should report the result because my data not normal, not homogeneous. That is why I am using non-parametric test. Okay, now I am using non-parametric test. Analyze, it is same as the independent t-test. Okay, and then analyze non-parametric test, 2 independent sample. So 2 independent sample. Okay, I am taking both the day data Sunday and as well as Wednesday. Okay, and type of drugs I am transferring group variables and define groups, the day group 1 and group 2, because I have coded 1 for ecstasy tablet, 2 for another group, alcohol group. Okay, and then continue, and then by default it is Mann-Whitney, and I will okay. I'm repeating again how to perform Mann-Whitney test. Analyze, non-parametric test, legacy dialogues, 2 independent samples, and then types of drug. I am transferring here grouping variables 1 and 2. Continue. I am selecting both the variables and transferring here, and then by default Mann-Whitney, I do not need to tick it, and then okay. Now what is my result? This is my result. So the mean rank of in a Sunday score for ecstasy tablet, the mean rank 11.95 and alcohol users 9.05. So we do not need to find the rank. SPSS automatically convert continuous data into ranking. So whether this difference is significant or not, question is it is different, but whether this difference is significant or not, who will tell us? P-value. So we check the p-value. So this is Sunday score, and asymptotically this p-value. So what is the p-value? It is greater than 0.05. It means after 1 day there is no impact of there is no significant difference found in patients of alcohol and ecstasy tablet users. No. Now the Wednesday, when we continuously give in tablet to the 10 participants, means Saturday, Sunday, Monday, Tuesday, and we observed their score on Wednesday. And another group, we have given alcohol on Saturday night, Sunday, Monday, Tuesday, and we observed their score. Now we will check whether this is significant or not. So okay, whether this is significant or not, who will tell us? This p-value, because the score Wednesday is 15.10 and 5.9, means it is different. But whether this difference significant or not, who will tell us? This p-value. Yes, this p-value. It means if we give the tablet continuously to the patient, then their health may improve. So p-value tell us whether the difference is significant or not. Now the another case study,
Excuse me, sir. Hello.
Yes,
sir. This is there now 1 tail or 2 tail. The result shows that there is 1 tail or 2 tail. Please explain this.
देखिए मैडम 1 tail
Previous slide, sir.
हाँ अभी बता रहे हैं.
The results show the 1 tail. Yeah, exactly. Please explain this.
कौन सा वाला?
The previous slide, the results slide.
Output ये वाला करें आप?
Yeah. Output
हाँ.
one. Right, sir.
Okay,
So then
okay.
assumptions 2-tailed. Okay,
हाँ.
thank you so much.
Okay. देखिए 1 tailed, हाँ, okay, thank you. देखिए जो 1 tailed, 2 tailed, there are 2 types of study, the 1 tailed and 2 tailed. When we take the 1 tailed and 2 tailed, this is upper tail and this is lower tail. The 1 tail means when we know the outcome. What would be the outcome? It means we are giving the medicines and we know that it will impact to the patients. Okay. Now this is the when we know the impact, we know that this would be the impact, or we are sure, then we take one sample, one tailed. Okay. And when it is there are 2 types of hypothesis. One is 1 tailed and second is directional and non-directional. Okay, directional and non-directional. 2 tailed means when we do not know what would be the impact, whether it would be it will improve the health or not. Okay, so when we do not know whether what would be the outcome, then we take the two sample two-tail test. Okay. Now third case,
The exact then?
मैडम एग्जैक्ट
Should we-
क्या देखिए
Exact,
एग्जैक्ट
which
देखिए
which will tell us the significant difference between the two groups.
मैडम देखिए इनका जो है ना, आप एक बुक है एंडी फील्ड की, डिस्कवरिंग ऑफ स्टैटिस्टिक्स बाय एंडी फील्ड. ओके, तो उसमें हाँ, तो डू यू हैव द बुक एंडी फील्ड?
Yes, I have.
हाँ,
Yes, sir.
उसमें बड़ा अच्छा क्लियर किया हुआ है, उसको आप जरा पढ़ लीजिएगा, है ना जी.
Okay, sir.
ओके,
एक्सक्यूज मी सर.
यस यस सर, यस सर.
सर ये जो आउटपुट आपने शो किया है, इसमें जो
जी, जी.
मीन रैंक वाली वैल्यू है, दैट इज इंक्रीजिंग फॉर द ड्रग. सो व्हाट डज दैट मीन?
Sir, it is hypothetical data. So increasing the means you can take it as the output. This is okay. So here the mean rank you are seeing here 11.95 and another is alcohol 9.05. Okay.
सर
So
मेरा एक क्वेश्चन था, इसको नीचे ग्राफिक फॉर्म में भी डिस्क्राइब किया हुआ है.
हाँ, ग्राफिकल भी इसको दिखा सकते हैं हम इसको. यस सर.
Is it explained down graphically or not?
हाँ, ग्राफिकली इसको हम शो कर सकते हैं सर.
अच्छा अच्छा.
हाँ, इसको देखिए मैं भी दिखाता हूँ ग्राफिकली भी हाउ टू डू. ये जो इंक्रीजिंग और डिक्रीजिंग वाले कौन सी वैल्यू बोल रहे हैं आप सर? ये कैस्टेसी टैबलेट का?
यस सर.
हाँ सर, इसको देखिए हम इंटरप्रेट ये भी कर सकते हैं. सो देयर इज ए सिग्निफिकेंट डिफरेंस. सो कि इसको अगर इंटरप्रेट भी ये भी करें कि कैस्टेसी टैबलेट एंड एल्कोहल, the higher the score means less depression. Okay, and lower the score may be the higher depression level. So it is depend on the scale कि वो हम स्केल किस तरीके से ले रहे हैं. अगर स्केल हम लें 0 to 10 या 0 to 100 means if you are taking high score then we can assume that high depression level. So there is one way. Or inversely we can see if you are giving the low score means high depression, high score means low depression. So ये डिपेंड करता है कि हमने स्केल किस तरीके से लिया. अगर हम जनरली जो स्कोर ले रहे हैं कि मींस लो टू हाई, ओके 1 to 100, देन उस केस में तो ये होगा कि एल्कोहल का जो इंटरप्रिटेशन होगा इसमें कि एल्कोहल डिप्रेशन लेवल को कम कर रहा है. ओके सर. सो और एक्सटेसी टैबलेट का इम्पैक्ट कम है. लेकिन अगर हाँ, तो ये डिपेंड करेगा सर हमारा कि हमने स्केल कैसे लिया है. कि इफ वी आर टेकिंग आवर स्केल मींस लो टू हाई, then it means the alcohol is reducing the depression level. Okay. और अगर हम ये करें कि हाई टू लो अगर हमने स्केल लिया है, then it means कि ये एक्सटेसी टैबलेट रिड्यूस कर रहा है डिप्रेशन लेवल को. Okay. Now next is the Wilcox-Conn.
Sir, one more question, sir, on this.
जी.
Sir, while reporting values for this Mann-Whitney U test, what are
Yes,
the
yes.
values that we need to mention when we are writing the results? Like mean,
Yes, yes.
rank, of course, we will
Okay,
be
okay.
mentioning. So
Yes,
what are
yes,
the
yes.
other values?
यस यस मैडम, बिल्कुल आपका क्वेश्चन अच्छा है. मैं भी एक हाउ टू रिपोर्ट इट, आई एम शोइंग यू दी आउटकम. देखिए मैं आपको दिखा देता हूँ. इसमें एक बुक है मेरे पास, बुक एंडी फील्ड बुक, दिस SPSS. Can you see this book? Is it visible?
Yes,
Please?
yes. Sir.
Okay, okay. देखिए एंडी फील्ड बुक है. वी विल प्रोवाइड यू दिस बुक और हाउ टू interpret the result. So I am showing you the non-parametric. देखिए बहुत अच्छा इसमें दिया हाउ टू रिपोर्ट
It
आवर
is
रिजल्ट.
already provided, sir. All
Yes,
these
yes.
ebooks are already provided to us by email,
Yes,
sir.
yes, yes. सर मैं इनको दिखा दूं मैडम को एक बार कि बिकॉज इसमें इतना बहुत अच्छा दिया हुआ है कि हाउ टू रिपोर्ट आवर रिजल्ट्स. I have taken all the case study from this book. So if you want to go through in depth, में देखिए आप जाना चाहते हैं तो you can go through this book and how to reporting. I am showing you. ये देखिए ये now is it visible?
Yes.
How to report? Yeah. The depression level in ecstasy tablet user in the first case did not differ significantly from the alcohol user, while the other depression level did not. इसमें जो result आया, because my data is different from this data, so here again the depression level did not significantly different from the alcohol users. So how to report, how to writing the result means independent t-test, pair t-test, ANOVA, repeated measures ANOVA, Mann Whitney, Wilcoxon, all the tests I have taken from this book. So you can report your result. You just go through the this book. Okay.
Okay, sir.
Thank you. Now the next is, because I have less time, so I just want to complete. Now the next is the this. देखिए कहीं से म्यूट कर लीजिए माइक किसी का जो है अभी माइक. हाँ जी ठीक है, थैंक यू मैडम. नाउ दी Wilcoxon this test. Okay, it is same as the pair t test. So here we are giving the tablets to the patients continuously. Okay, so then how to perform it? Pair t test. Pair t test means Wilcoxon rank sign test. Analyze, non-parametric test, legacy dialogues, two related samples. Okay, two related samples. So two related samples, and then I am transferring both the variables, and by default you can see Wilcoxon, and then okay, and after okay, so you can see the result. So it means there is a significant impact because p value here less than 0.05. If we give the, we will report, if we give the continuously to the tablet to the patients, then it reduce the depression level. How to report? You can report through this table. You can use this. Okay, so this is about the Wilcoxon rank sign t test. This is my result. Okay, now how to report this? So you can report this. This is the result. The for ecstasy tablet user, depression level was significantly higher on Wednesday. And another report किया उन्होंने, the ecstasy user depression level were significantly higher on Wednesday. और इसमें इन्होंने दिया है median value, Z value, P value and R. Okay. Now we use Kruskal-Wallis test. In this Kruskal-Wallis test, in this case study, we want to know whether coffee consumption increase heart rate score or not. So there are 4 groups. One group we are not giving coffee to the 10 participants and we are measuring the heart rate score. Now another group we are giving 1 cup coffee per day and measuring the heart rate score of 10. And then another third group we are giving 2 cup coffee per day and measuring the heart rate score. And fourth group we are giving 4 cup coffee per day and we are measuring the score. So we want to know whether the coffee consumption coffee consumption increases heart rate score or not. So we are comparing several means no cup coffee, 1 cup coffee, 2 cup coffee and 4 cup coffee. It means we are using Kruskal-Wallis test equivalent to the analysis of variance. How to perform in non-parametric? Analyze non-parametric test and K independent sample. K independent sample. And then coffee consumption, I am transferring here. Define range 4. No cup coffee, coding 1 and maximum 4. And then continue. And then heart rate score I am transferring here. So by default, you can see here Kruskal-Wallis test. And then OK. And after OK, we will see the output. So my output is this. No cup coffee mean rank is 16.35, 19.65, 14.65, 31.35. It means different. All the values are different. Whether this difference significant or not, who will tell us? P value. The asymptotically significant value, it is less than 0.05. It means there is a significant impact. So in this way, we do not have option to check the post hoc analysis test, but we can check post hoc analysis through another way. So there are two ways to check the post hoc analysis test. One way to analyze non-parametric legacy, so independent sample. There is one way to check the post hoc analysis test through this way, and another way we compare 3 times Mann-Whitney U test. So analyze non-parametric test legacy.
सर
yes.
सर
yes.
ये पोस्ट हॉक एनालिसिस किस लिए करते हैं?
सर पोस्ट हॉक एनालिसिस इसलिए करते हैं कि हम जैसे हमने ये फाइंड किया है कि क्या कॉफी कंजम्पशन का इम्पैक्ट होता है, तो ये तो पता चल गया कि यस देयर इज ए सिग्निफिकेंट इम्पैक्ट ऑफ कॉफी कंजम्पशन की 1 कप। अब हम ये देखना चाह रहे हैं कि 1 कप कॉफी पीने से हार्ट रेट बढ़ता है या 2 कप कॉफी से या 4 कप कॉफी से, तो ये हमें नहीं बताया उसने। तो इसके लिए क्या करेंगे हम 3 बार मैन-वाइटनी नो कप कॉफी विद 1 कप कॉफी, क्या इसकी वजह से बढ़ता है, या नो कप कॉफी 2 कप कॉफी, क्या 2 कप कॉफी की वजह से बढ़ता है, या नो कप कॉफी 4 कप कॉफी। तो 3 पेयर्स हमारे होंगे। तो फिर हम देखेंगे कि नहीं कि जो पोस्ट होक एनालिसिस हमने इसलिए किया है कि एग्जैक्टली हमें पता चल जाए, क्योंकि ट्रीटमेंट हम 3 ट्रीटमेंट कर रहे हैं, 1 कप कॉफी, 2 कप कॉफी और 4 कप कॉफी। अगर हमें लग रहा है कि 4 कप कॉफी पीने से जो बढ़ता है हार्ट रेट स्कोर, तो 1 and 2 कप कॉफी यू कैन टेक इट। ओके, तो इसको कंपैरिजन करने के लिए हम लोग जो है पोस्ट होक एनालिसिस करते हैं। तो मैंने बताया कि 2 तरीके से कर सकते हैं, एक तो ये है, दूसरा तरीका इसमें और भी है। अभी मैं एनालाइज कर रहा हूं, आई एम एनालाइजिंग थ्रू 3 टाइम्स मैन-वाइटनी यू टेस्ट के थ्रू। ओके, सो एनालाइज नॉन पैरामेट्रिक टेस्ट legacy 2 independent sample. So coffee consumption here means 1 and 2 group, means 1 cup coffee, no cup coffee and 2 cup coffee. So then continue, then transfer here heart rate score. It is simple Mann-Whitney test, Mann-Whitney U test. And what is the result? The p value 0.404. It means 1 कप कॉफी पीने से, ये पोस्ट होक एनालिसिस हो गया एक तरह से, 1 कप कॉफी पीने से जो हार्ट रेट स्कोर सिग्निफिकेंटली नहीं बढ़ता, बिकॉज पी वैल्यू ग्रेटर देन 0.05। अनदर जो कंपेयर करेंगे मींस एनालाइज देन नॉन पैरामेट्रिक एंड लेगेसी 2 independent sample. So I am changing it, 1 no cup coffee with 2 cup coffee. क्या 2 cup coffee पीने से बढ़ता हार्ट रेट सिग्निफिकेंटली या नहीं? Continue and then okay, yes. What is the p value? 0.85. No, you can take 2 cup coffee per day. You will not आपका हार्ट रेट सिग्निफिकेंटली इंक्रीज नहीं होगा. Now I am comparing 1 cup coffee with 4 cup coffee. So analyze non-parametric and then 2 independent sample, this 1 and 4, 1 cup coffee with 4 cup, 1 and 4. Okay, continue and okay. Yes, the p value is 0.034, less than 0.05. It means your heart rate will increase significantly if you drink 4 cup coffee per day. Now next case study, Friedman ANOVA. So it is the related to the sales.
Sir.
Yes sir.
सर ये क्रुक्सल वॉलिस वाला एक बार और रिपीट कर देंगे?
बिल्कुल कर देंगे भाई साहब
जी सर।
वैसे आपके पास रिकॉर्डिंग भी है ना, देख भी सकते हैं, लेकिन आपने
स्क्वायर कवर होगा आज स्क्वायर
बिल्कुल हो जाएगा मैडम, अगर कोई डिस्टर्ब नहीं करेगा मुझे तो काई स्क्वायर भी अभी हो जाएगा। बीच बीच में सवाल पूछेंगे तो लेट हो जाएगा। अभी देखिए, मैं देखिए अभी एक बार फिर कर रहा हूं, ये देखिए परफॉर्म आपने कहा दोबारा से करना ना इसको। सर देखिए, एनालाइज क्रुस्कल वैलिस एंड देन नॉन पैरामेट्रिक टेस्ट एंड देन के इंडिपेंडेंट सैंपल्स। ओके, तो इसमें देखिए जो कॉफी कंजम्पशन आई एम ट्रांसफरिंग हियर, डिफाइन वेरिएबल्स 1 and 4 continue and heart rate score here. Then by default you can see Kruskal Wallis test, we do not need to tick here, and then okay, and this is the result. So what is the p value? P value is significant difference. तो यहां से हमें पता तो चल गया सिग्निफिकेंट डिफरेंस है, लेकिन ये नहीं पता है कि 1 कप कॉफी का से इंक्रीज हो रहा सिग्निफिकेंटली 2 कप कॉफी से हो रहा है या 4 कप कॉफी। सो उसके लिए हमने पोस्ट होक एनालिसिस किया, और एक अलग भी मेथड है वो उसके थ्रू भी हम कर सकते हैं। अब फ्रीडमैन एनोवा, तो इन फ्रीडमैन एनोवा में बेसिकली इट इज इक्विवेलेंट टू द रिपीटेड मेजर्स एनोवा। सेल्स means baseline sales, we used marketing campaign, and after 1 month sale noted, and then after 2 months. So this is the baseline. Okay, and after 1 month sale we observed, and after 2 months we want to check whether this marketing campaign worked or not. Okay, so here we can see there is not a difference much, but we cannot say right now because p value tell us whether the marketing campaign successfully worked or not. So it is same as repeated measures ANOVA, but we are using non-parametric test equivalent of repeated measures ANOVA, Friedman ANOVA. Okay, so analyze non-parametric test, legacy dialog, and k related sample. 2 related sample means Wilcoxon rank sign test. K means more than 2 groups, and then we will select all the 3 variables and transfer here, and by default it is Friedman ANOVA, and it is okay. And after okay, what is the result? This is the result. So sale at start 2.2, 1.8 and 2. There is difference, but whether this difference significant or not, this p value tell us. P value greater than 0.05, so it is not significant, means marketing campaign not worked. Now my last case study, chi-square test. It is related to the chi-square test. So yesterday I discussed the chi-square test we use when both the variables categorical variable. So here one trainer is giving training to the cats, and in this case study 150 cats, we have taken 150 cats, and the trainer wants to know whether whether affection as a reward work or food as a reward. Okay, so he given food to the 10 about food. He provided food 30 cats. He provided food to 30 cats. Out of the 30 cats, some cats are dancing because he wants whether food reward as a work or not for trained the cats. So some cats are dancing, and here some cats are still not dancing. even he is giving food as a reward to the cats. And second reward is affection as a reward. When he is giving affection to the cats, some cats are dancing, and most of the cats are not dancing. You can see. Okay. Now, so here we want to know whether affection as a reward work or food as a reward. Now, how to perform it? Analyze descriptive statistics. I am performing chi-square test. Analyze descriptive statistics and cross tabs. And cross tabs, the types of training row and type the dance in column, and exact, nothing to do here. And then statistics, the chi-square, and then continue. After continue, cells, expected and observed, I tick, and then row percentage, and then continue. And statistics, yes. And then for nothing to do here, format, and then continue. Okay. Now, okay, what is the output? Now, this is the output. So we have taken 150 cats for dancing purpose. So food as a reward. So 30 cats we given food as a reward. Out of the 30, 20 cats dance and 10 cats did not dance. It means 66.7% cats dance and 33.3 cats did not dance when we provided the food. Second is affection as a reward. The affection as a reward, we have given 120 cats affection, and out of the 120, 45 means 30.5%, 37.5% dance, and 62.5% did not dance. So here we can say food as a reward is working. But whether it is significant or not, who will tell us? This p value, asymptotically p value, and this is the value of chi-square 8.314, and this is the p value. It is less than 0.05. It means for animal, food as a reward works. Okay, so this would be our interpretation. So thank you very much for today lecture. So if you have any query, one or two, we can take it within.
Sir, I have certain questions. Hello?
Yes, yes.
Sir, first question I have: how to perform chi-square test with the contingency tables?
Contingency, madam, this is contingency table. This table known as the contingency table.
Okay.
Sir, please repeat the steps of chi-square.
क्या मैडम?
Please repeat the steps of chi-square test again, sir.
ठीक है, वैसे मैडम आपको ये मिल जाएगा जो इसकी रिकॉर्डिंग है, लेकिन फिर भी मैं आपको एक बार, आपने कहा है, मैं इसको रिपीट कर देता हूँ. ये देखिए इसमें देखिए एनालाइज एंड देन descriptive statistics and explore. ठीक है, and okay, and after this, so type of training you can put either dependent or cross tab. Analyze, descriptive and cross tab. Okay, cross tab. Then you can transfer types of variable row and dance in column, and statistics you tick chi-square, and then continue, cells, observed, expected and row, and continue, and then okay.
Thank you, sir.
Sir, I have three more questions.
मैडम मैं केवल देखिए अभी इसमें हमारे पास इतना टाइम नहीं है कि पूरी क्वेरी ले सकें, ओनली 1 or 2 क्वेश्चन हैं, ले लीजिए. इसके बाद आप मेरा मोबाइल नंबर मैंने शेयर किया है, आप इसके बाद भी जो है हमसे अपने ज्यादा से ज्यादा क्वेश्चन पूछ सकते हैं, है ना.
सर
बुक आप सर मेल करेंगे या व्हाट्सएप करेंगे?
एक क्वेश्चन तो बोल सकते हैं.
हाँ, एक क्वेश्चन पूछिए मैडम, बिल्कुल पूछिए.
हाउ टू कैलकुलेट द इफेक्ट साइज?
देखिए इफेक्ट साइज का ये जो बुक है मैडम, ये इस बुक में हमने इफेक्ट साइज का निकाला हुआ है कि कैसे कैलकुलेट करते हैं. तो इस बुक को आप जो है ना, एनडी फील्ड की जो बुक है, इसमें आप इफेक्ट साइज का ये जैसे लिखा हुआ है, इफेक्ट साइज कैन बी कैलकुलेटेड दिस टेस्ट। तो इसमें इस इफेक्ट साइज के कैसे कैलकुलेट करते हैं वो इसमें मेथड दिया हुआ है। एक्चुअली इसका फॉर्मूला होता है, फॉर्मूले में वैल्यू पुट करके जो है हम इफेक्ट साइज को फाइंड आउट कर सकते हैं, है ना। इस बुक में बड़े क्या मैडम,
SPSS में हम कैलकुलेट नहीं कर सकते इफेक्ट साइज।
हाँ देखिए, इसमें हमारे पास फॉर्मूला होता है एक्चुअली इफेक्ट साइज करने का, हर एक टेस्ट का अलग अलग है। तो इसमें बड़ा अच्छा समझाया हुआ है कि अगर आप जो है इंडिपेंडेंट टी टेस्ट का, पेयर टी टेस्ट का, हर एक का आप इफेक्ट साइज इसमें कैलकुलेट कर सकते हैं। उसके अलग अलग फॉर्मूले में वैल्यू पुट करनी पड़ेगी। जी
मेरा क्वेश्चन है आपसे,
पूछना चाह रही थी आपसे
क्वेश्चन है
जी सर।
कुछ
will you also discuss about the plasma, how plasma is detected, what are the measures to calculate the plasma?
प्लाज्मा
हाँ सर, क्रिएटिव थिंकिंग और ये
हाँ नहीं, मैं आपका क्वेश्चन नहीं समझा सर। जो मैंने आज पढ़ाया उससे रिलेटेड है क्या?
सॉरी सर, सॉरी
जी जी
सर, ये बुक आप सर मेल कर सकते हैं।
I have a question with regard to the homogeneity of variance.
जी
Sir, just like normality tells us whether our data approximates a normal distribution, what is the conceptual purpose of homogeneity of variance? What does it tell us about the data?
देखिए, होमोजेनिटी के लिए मैं आपको बता देता हूँ। आपका देखिए क्वेश्चन लास्ट क्वेश्चन होगा, बाकी आप मुझसे कल दिन में फोन पे भी पूछ सकते हैं क्योंकि काफी टाइम हो गया है। अब देखिए, होमोजेनिटी का मैं कॉन्सेप्ट बता देता हूँ आपको।
थैंक यू सर।
हाँ बता रहा हूँ मैडम।
आप मेल कर सकते हैं सर।
सर वो कर चुके हैं सर अभी। सर
मुझे मेल नहीं हुआ ना सर, ग्रुप में व्हाट्सएप में आया ना, मेल आया है सर मुझे।
सर मिल जाएगी बुक की, कोई चिंता नहीं है। मेरा ईमेल आईडी आपको मैंने शेयर कर दिया, फिर कर दूंगा, मैं आपको कर दूंगा आज बुक, है ना। तो मटेरियल की कोई प्रॉब्लम नहीं है। जो मेरे वैसे तो विशाल सर दे देंगे, अगर मान लिया रह गया है कोई, आप मुझे व्हाट्सएप कर दीजिए अपना ईमेल आईडी, मैं आपको बुक दे दूंगा। जो मटेरियल चाहिए सारा मटेरियल मिल जाएगा आपको, ठीक है। देखिए ये मैं कॉन्सेप्ट बता रहा था इसका, ये लास्ट क्वेश्चन है बस। ये देखिए होमोजेनिटी का, होमोजेनिटी बेसिकली जो है का जो कॉन्सेप्ट होता है कि ये जो मान लीजिए हमने ये 1 लाख रुपीस एडवर्टाइजिंग एक्सपेंसेस, 2 लाख रुपीस एंड 3 लाख रुपीस। ओके, नाउ व्हेन वी spend 1 lakh rupees, my per day sales 10 lakh rupees, sorry, mean sale, okay, and the 20 lakhs and another 30 lakhs. Okay, so when the this is the mean sale, means 1 week sale, means one day my sale would be 15 lakh, another day 14, and someday it may be 7 or 8. So this is the range. Okay, so this is the range and my data normally distributed. Now when we spend 2 lakh rupees, the distribution someday may be 25, 24, 23. This is the range. For example, this is the range 10 lakh, 10. Okay, and this is also range 10. So the variation of the data across the group, it is same. So again the maximum 35 and 25. So here this is the range. When the range constant across the group, so it means my data homogeneous. If so 30 lakhs may come also, one day sale may be 50 lakh and another day this. So this is not homogeneous data because it is heterogeneous, because dispersiveness in across the group, it is not same. If this is okay, when dispersiveness across the group or constant across the group same, then my data is homogeneous. Okay, so thank you very much.
Thank you. एक लास्ट क्वेश्चन पूछ सकती हूँ सर?
मैडम कल पूछ लीजिए, देखिए टाइम हमारा आधा घंटा और ऊपर चला गया आज।
सर एक सिंपल सा क्वेश्चन है बस।
जी देखिए, हाँ पूछ लीजिए। वैसे मैंने आपको कहा ना मोबाइल नंबर भी है, उसके बाद भी पूछ सकते हैं।
मुझे सिर्फ ये पूछना था कि जैसे हमारे बहुत सारा डाटा ऐसा होता है, जैसे 5 फ्रीक्वेंसी नहीं है ईच सेल की, तो हम काई स्क्वायर नहीं लगा सकते, तो हम एसोसिएशन उससे नहीं निकाल सकते। तो अगर जैसे हम एनोवा के थ्रू जो इंटरेक्शन निकालते हैं, उसमें और काई स्क्वायर में क्या डिफरेंस होता है?
देखिए काई स्क्वायर और एनोवा में बहुत डिफरेंस है. काई स्क्वायर टेस्ट कैन बी यूज्ड ओनली फॉर कैटेगरिकल डेटा. एनोवा में हमारे पास एक कैटेगरिकल डेटा होता है और एक हमारे पास कॉन्टिन्यूअस डेटा होता है. तो ये डिफरेंस है. मैंने कल भी बताया कि कोई भी स्टैटिस्टिकल टूल टेक्निक यूज करने से पहले हमें ये देखना होता है कि डेटा हमारा कैटेगरिकल है कि कॉन्टिन्यूअस है. तो इसमें बिल्कुल जमीन आसमान का अंतर है. कैटेगरिकल डेटा के लिए काई स्क्वायर टेस्ट हम यूज कर सकते हैं और एनोवा जो है वो बिल्कुल डिफरेंट है. इसमें एक वेरिएबल डिपेंडेंट वेरिएबल कॉन्टिन्यूअस होना चाहिए, एक इंडिपेंडेंट डिपेंडेंट कॉन्टिन्यूअस और इंडिपेंडेंट वेरिएबल कैटेगरिकल, जिसमें 3 या 4 कैटेगरी हो. ठीक है ना. और जी थैंक यू वेरी मच.
थैंक यू सो मच सर.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you, sir. Thank you, thank you, thank you. Thank you, okay.
Thank you very much. Thank
Fantastic,
you.
fantastic.
Thank you, thank you, thank you. Sir,
Excellent.
after this lecture you can most welcome. कभी भी कितनी बार भी डिस्कस कर लीजिए. अभी है टाइम का कंस्टेंट है, इस वजह से ज्यादा क्वेरी नहीं ले पाएंगे. ठीक है सर.
Okay sir. Okay. Thank you sir.
बहुत अच्छा
Amazing
explain किया. Thank you.
patience by the teacher. Amazing patience by the teacher, and what fantastic hold on the subject.
Thank you, sir.
Wonderful, sir. Wonderful.
Shailesh sir, you also please share your number, sir. Shailesh
Yes,
sir,
yes sir.
share your number also, sir. Please.
ये देखिए मैं शेयर कर चुका हूं सर. एक बार फिर आप चाहें तो इसको नोट कर लें.
Thank you.
Thank you, sir.
ठीक है, मैं शेयर कल कर दूंगा सर. ठीक है जी. ये देखिए नंबर.
Okay sir. Okay sir.
Thank you, sir.
Thank you everyone.
I'll start the audio.